Hi viewers, here this video explains inserting node at end of the circular linked list. So here if the list is empty, then add the new node as a head of the linked list. If the linked list is not empty, then find the last node and make it the last node next is a new node. Last dot next dot next field as a new node. Then new node will become as a last node, that will be the tail pointer of the list. Okay, so here already I told you the list can be accessed by using the head, right? Our list can be accessed by using the tail pointer. So when you are using the tail pointer, then the last node you are going to insert, that will act as a new tail. That's why we are using this statement. Okay, this will become the new tail. Okay, so here we can use the head pointer, here we are using the tail pointer representation for accessing the list. So first we will see head pointer to add the a node at end of the list. If I am using the list like this, okay, initially I am checking the list is empty or not. If the list is empty, the new node will become the head and the new node will become the tail. Okay, that means if it is null, okay, if it is null, head equal to null, then it is empty list. Okay, tail also will have the null, right? So then new node is going to add into the list. So here the new node is represented by both head pointer. So here your null pointer will be written as 500 and tail also will point to the uh, new node. So this also will be going to represent as 500. Then the new node tail dot next will become as a head. Okay, head or new node. Okay, so that is the thing. But if I have more than one node in the list, if I have more than one node in the list, this list also I am accessing by using the tail pointer. I am using, sorry, head pointer. I am using head pointer to access the list. So if it is the case, then it is 781, here 101, 102, 103, and here 102, address of second node, address of third node, address of head node 101. So here this is header. So I am using header to access the list. So if it is the case, what I have to do, I am assigning the header to temporary variable, right? So I have to move into the last node. I have to move into the last node. For that, so this is the temporary dot next. So head is last node is having the address of head. That's why we are using the condition temporary dot next not equal to head. Yes, temporary dot next is not equal to head, it is true. Then temporary is updated. Now temporary dot next is 102. Okay, 102. So now temporary is updated, so temporary is becoming 102. Then again we are checking temporary dot next, that is 103, not equal to head. Yes, temporary dot next not equal to 103, right? So here, which is true. So what we are doing, we are assigning temporary dot next is 103. So 103 is assigned into the temporary. So this is updating temporary, right? So now temporary is 103. Again we are checking temporary dot next, iteration number 3, temporary dot next not equal to head. Temporary dot next is 101. 101 is the head. You look at here, this is the head. So condition is true. So now the new node is going to insert at end. So the temporary dot next, okay, temporary dot next will become the new node if it is having the address. So temporary dot next is updating with 500. So the link is created like this. Okay, the new node dot next, right? New node dot next is assigned to head. So here this is having the address of head 101. So now the node is assigned into the last. So now the tail pointer also you have to change the tail equal to now new node, tail equal to now new node. Okay, so this is the way to add the node at the end of the list by using head pointer, suppose. So here your time complexity is order of n, because we are moving from first node to last node, so order of n. But same case, if we use the tail pointer to access the list, my list is having three nodes like this. Okay, now I am having the address 101, 102, 103. So first node is the head. Okay, here which is having the 101, the tail, so tail is having 103. The first node is having address of second node is having address of third node, the tail node is having address of first node, address of head node. Okay, now I am going to use the tail pointer to access the list, tail pointer to access the list. If it is the case, directly I can access the tail without using the, without moving from head. So I can access the tail pointer at the first attempt directly. So here I am saving the time complexity. I need not to move step by step. So here I am going to use tail pointer to add the new node. So this is the new node. So if it is the case that directly tail dot next will become the new node. Okay, so which is going to be updated with the address of new node 500. The new node dot next will become the head. Okay, so 101 is going to be right here. Now tail node is the new node. So we added the node at the end of the list. Okay, so this is the way to add the node at end of the list. So here you see I am using only order of 1. Directly we are accessing the list by using the tail pointer. Okay, so but previously we are using the head pointer but order of n. So this is the difference. So mostly inserting the node at the end of the list in circular linked list by using the tail node. Then